Electrical Connectors France as a master data manager. So today I will present my work about characterization of integrated lean tools adapt to the upstream phase of product life cycle of Stobli electrical connectors. This work was done in collaboration with Neja Elafri from Constantine University and my PhD supervisor, Bertrand Rose from Strasbourg University. So this is the outline of this presentation. So at first, I want to present the industrial and scientific context. Then I want to introduce the integrated lean vision. The third point is on the characterization of integrated lean tools. And finally, I will do a quick synthesis and present opportunities of this study. So let's start with the industrial and scientific context. So the company where I work is Stobli Electrical Connectors France. So it's based in Ezang, in the east of France, near the city of Basel in Switzerland. So we are a part of the electrical connector division of the group Stobli. And we are a production and commercial unit specialized on the highway and e-mobility. So we are a competence center for these two markets for the group. So we produce a large range of products, like standard catalog products. You can see here our solar panel connector MC4. We also develop and produce some specific and modular solution for our customer. You can see here some railway connector, and we also have research and development activities. And you can see here our quick charge connection system for autonomous vehicle. So I will continue to present the context with the market requirements. So the electrical connector market is constantly evolving and is subject to a big technological and competitive pressure. So you can see here the three main factors taken account by customer to choose a supplier. So it's really classic. It's time, cost, quality. And we observe now in the electrical connector market that the quality and the cost are no more the main lever for customer to choose a supplier. And we saw that the delivery time become even more and more important. We also noticed that the customer service became more and more important and be a new selection lever for customer. So in addition, we also noticed that the markets are changing. Yeah. So now customer want to buy a complete function who provides a complete solution of the product, and no more just a simple connector, simple component to integrate. So you can see here the transformation of our market. So from basic couple of connectors to global system. So now we come to the first industrial problem. So how to deliver more complex product in a shorter time frame. So I will continue with the operational requirement. So in the 50s, Charles Kepner defined a marketing rule who defined the success factor of a product. So it's to have the right product at the right time, on the right price at the right quantity, and on the right market. So all these factors are defined during the development and launch phase of the product. So all product characteristics are defined during the upstream phase of product life cycle. So we can say that the early phase of product life cycle is a key period for the success of a new product. So now we come to the second industrial problem. So how to improve industrial performance during the upstream phase of product life cycle. In this slide, I want to go more in detail about the upstream phase of product life cycle. So you can see here the Stobli electrical connector innovation process. So it's called ECS gate, and it's based on the state gate model defined by Cooper. And you can see it's a project overview of the upstream phase of product life cycle. So you can see on the middle the innovation funnel, and on the right you have the bell curve of the product life cycle. we can also define two big stages, the development stage and the product launch stage. And we can say that the innovation process is a succession of stage and milestones. I will continue to describe the upstream stage of product life cycle. So previously we saw the project overview, and now this is the operational overview of the upstream phase of product life cycle of stable electrical connectors. So you can see on the top all operational activities during the development and product launch stage. And under you have the different departments who have to do these operational activities. And the link between these different departments are our information system. So now we arrive to the second part of this presentation about the integrated lean vision. So at first, I want to introduce the general lean vision. So now lean is quite familiar, so I don't want to make big presentation. I just want to highlight a few points. So the lean is a well-proven methodology to improve performance of industrial company. The lean is focused on value added and on the elimination of waste. And the lean classified this waste in 7 categories, so we can see them here. So inventory, overproduction, waiting time, transportation, overprocessing, motion, and defect. The lean is native from the production workshop, but is now declined for a large panel of activity and environment. So we now found lean management, lean service, lean software development, and other. So we arrived to our first scientific problem. So what type of lean to apply to improve performance during the upstream phase of product life cycle? So we try to identify all lean environments present in the upstream phase of product life cycle of stable electrical connectors. So here on the top you can see the innovation technology, information technology ecosystem of the company. So on the middle are ERP, and linked around all software who manage drawings, customer information, operational activities, marketing, or even projects. On the middle, you can see the project, the innovation process that we saw previously, so the project overview. And on the bottom, you have the operational process. And for each environment, we found a declination of an adaptation of the lean method. So for the information technology, you have the lean IT. For the innovation process, lean product development. And for the operational process during the upstream phase of product life cycle, the lean office. So now we can introduce the integrated lean notion. So we saw previously that the upstream phase of product life cycle is composed by 3 strongly interconnected and interdependent environments: product development, operational activities, and information technology ecosystem. And because of these independencies, use a lean approach on only one environment have a limited effect and impact. So we suggest to have a global approach of the lean during the upstream phase of product life cycle that we called the integrated lean. So this gives us our second scientific problem. So what are integrated lean tools and when apply them? So now we arrive to the third part of this presentation, characterization of integrated lean tools. So in this part, we will try to answer to the question, what are integrated lean tools and when apply them? So to answer to this question, we perform a bibliometric study by reviewing articles from the Google Scholar database. So at first, we focus our research on the integrated lean notion and lean in the upstream phase of product life cycle. But these notions are quite new and not really described in the literature. So this is the originality of this work. And so we change our strategy due to the lack of data, and we focus on the lean adaptation present in the 3 environments of the upstream phase of product life cycle. So Lean IT, Lean Product Development, and Lean Office. So to answer to the first part of the question, so what are integrated Lean tools? We perform a review of 40 articles about Lean IT, Lean Office, and Lean Product Development. And during this review, we try to list all Lean tools put forward by the authors. So you can see here in this graphic all tools listed and how many times they appear for each time of Lean adaptation. So we analyze recurrencies and matching of these tools, and we saw that only 6 tools are common to the 3 environments. So these 6 tools are value stream mapping, standard work, KPI, A3 problem solving, Hijunka, and DMIIC. So we also noticed that a lot of tools are really specialized and dedicated to one environment. So you can see in on the right. To answer to the second part of the question, so when apply integrated Lean tools, we saw previously that the Lean method is focused on reducing waste and that these waste are declined in different type of waste, the 7 MUDA. So in this part, we try to establish a link between the 6 major Lean tools, integrated Lean tools that we just defined before, and the 7 MUDA. So to do that, we analyze 20 articles and to know which tools have an impact on which type of Lean waste. So here you can see the result, the impact of the integrated Lean tools on the 7 MUDA. We noticed that some tools have a really wide impact, like value stream mapping or A3 problem solving, and that some tools are more dedicated, like KPI. So now we arrive to the last part of this presentation. So I would like to resume some important points of this study. So the industrial context of the company gives us the first industrial problem. So how to deliver even more complex product in an even shorter time frame. So we see that the upstream phase of product life cycle is the key moment for the success of a new product. The second industrial problem is how to improve industrial performance during the upstream phase of product life cycle. And we show that the Lean is a well-proven method to improve the industrial performance of company. And we also saw that the Lean method is now declined for a very large panel of environment and activities. So the first scientific problematic is what type of Lean to apply in the upstream phase of product life cycle. And here we show that the upstream phase of product life cycle is composed by 3 strongly interdependent environments. And we suggest to use a global approach of the Lean in the upstream phase of product life cycle that we call integrated Lean. The second scientific problematic is split in 2 parts. So the first, what are integrated Lean tools? So we perform a bibliometric study that reveals the 6 major integrated Lean tools. So VSM, standard work, KPI, A3, Hijunka, and DMIC. And for the second part of the scientific problem, well apply these integrated Lean tools, we try to make the link between the tools and the MUDA defined by the Lean. So okay. Yeah. So for the last point, to try to understand the impact of these tools on this Lean waste and to adapt the use of these tools to the need to the company. So to finish, I want to present the limitation and opportunities of this study. So the main limitation of this work, as all bibliometric analysis, is that the data doesn't come from the field, but from the state of the art, the existing state of the art. So we need a validation we need a field assessment to validate our conclusion. So the next step of our work is to perform a field study to compare and to match with this bibliometric analysis. So we already launched a survey in the different plants of Stobli and other companies to have field data to analyze with the AHP method. And the final goal of this research work is to define.
So, any questions? No questions? You are not interested in lean for upstream. So you are planning to have a practical, let's say, feedback from different design offices. Who will be the people who are going to reply to your questionnaire? Or
yes. So,
how are you going to investigate?
Yeah.
And who will be the people target for this second stage?
I think people target are all people who involved in this upstream phase of product life cycle. So project, design office, the upstream supply chain, so purchase a lot. Also all people who work about industrialization of the product. So all people who work in the project phase.
Okay.
Of a new product development.
Did you already elaborate the material that you would like to share with them? So is it a questionnaire?
We already launched a survey.
A survey already, yes?
Yeah, so we wait to have some data to analyze.
Okay, and because you did not show that, I think, what are you expecting from that with respect to state of the art?
So we expecting to have some...
sorry, I reformulate my question. In your survey, are you giving some parts of the conclusions of that, and are you expecting some yes or no with respect to some analysis results that you had with the bibliographic or state of the art?
So we already want to compare the bibliometric analysis with the field data. Mm-hmm. So we want to compare some data with the field information with the AHP methods. So it's
AHP.
Yes.
Okay. And so Staubli, they are expecting some conclusions in order to maybe to change their good practices, or what will be the consequence of your study?
So already we try a bottom-up, a top-down approach. So from the Lean IT, because I am a master data manager, and we saw that there is not a fully perspective with this approach, and we try to have a more global approach on the global processes.
Okay, because at the end you mentioned a list of tools.
Yes.
These tools are already used inside the company, or
not all, and
not all
for the upstream phase of product life cycle.
Okay, so, and did you already formalize some kind of framework that could be?
Yeah, we try between the different plants of the electrical connector division to have the same framework of tools.
Okay, so you did not show everything there. Okay, no. So if you ask questions, you have additional information. So ask questions. No more questions? Okay, you have a second chance during the. So the next speaker comes from Brazil.
Yes. Can I use my computer or?
No. You have to put it on a USB key. I think so. Yes. They have to put the file on the USB key.
I think it's already here, but I don't know how to use this system.
Okay, so you will get some help.
Okay, thank you.
From that guy. There is a key here.
Yeah, so the section 6.
You need to connect there? Yes, okay. Why not?
Oh.
Okay, good.
Okay.
Good.
So where is your?
No, this one, the second one. No, the next, the second. 1, 2.
No, this one, this file. It's over there, yes.
Okay.
So, the second speaker
Let me see how
is Souza Rafael Odebrecht. and he's going to report about literature review and SWOT analysis concerning the use of Toyota Kata approach. I don't know if somebody in the room is practicing judo or aikido, and you know about the kata, okay? So in fact, it's the way of doing kata, the basics. I hope I am right.
Yes, you are
Yes,
right.
because I wrote, sorry, I read your paper as well.
Oh, okay. Good to know, good to know.
Anyway, well, so you have the floor for 15 minutes,
Okay.
and then we will try to have more questions from the
Okay,
room.
thank you.
Okay, so please push the audience.
Thank you very much. Okay, so good afternoon, everyone. My name is Rafael. I'm from Brazil, the Federal University of Santa Catarina. So this paper comes from my PhD research. I am researching human factors associated with the Industry 4.0 context, actually being called now Industry 5.0. And in my PhD thesis, I am trying to use the Toyota Kata approach to centralize the decision-making on employees. So one of the parts, the small part of my research, is to conduct a literature research about Toyota Kata. And this part of my PhD, actually, I transform it in this paper, and I am presenting here to you guys. So the Toyota Kata production system, entitled like lean manufacturing, has become a popular method to Western companies that want to be more efficient. So a lot of companies did start using the lean management or the lean approach, but not all of them have succeeded on using them. So Hotter went to the Toyota company, and he was interested in know how does Toyota continuously improve the production system. And he described this thing that he called Toyota Kata. So the book describes a routine already practiced by the Toyota company without showing its implementations in other organizations. So it's a routine already that Toyota uses, but so the objective was to look in the literature and see other companies are using this approach, how they are using, what they are doing to implement Toyota Kata in their companies and their manufacturing systems. So this is the main goal of conducting the systematic literature review. And we also propose a short model of how to implement the Toyota Kata approach. We also did a SWOT analysis. So a little bit of a theoretical background. So a Toyota Kata is a continuous improvement routine that provides people training based on applying scientific methods for sustainability solving problems. The SWOT methodology is a tool to characterize the analysis of strength, weakness, opportunities, and threats of something that you are searching for. So it's considered a robust approach to summarize the results and allow to present all the information collected in the literature review with a visualization approach that is useful to better frame the different instruments. This is why we use the SWOT approach when researching about Toyota Kata. So we conduct a systematic literature review using the systematic search flow method described by Farrehofen and Fernandez. And the focus was Toyota Kata in manufacturing companies. We searched for leading journals, conference proceedings, master's dissertations, and PhD theses. And the databases was Scopus, Web of Knowledge, Engineering Village, ProQuest, and we also did exploratory research using Google Scholar, who did bring a lot of information for us, but we were able to use some of that information in this paper. And the query used was Toyota Kata. So I will bring just the results. I will not extend about talking what is Toyota Kata. You can read in the paper. But from the content analysis, it became clear that before starting to actually optimize the production system, several works discussed the importance of conducting training phases so that everyone in the manufacturing system knows how to use the Toyota Kata approach. Some authors then suggest an interactive process, such as the use of gamification and a dry run training for a period like for 4 weeks. And during this phase, trainers should be encouraged students to think and develop new solutions using the PDCA cycle that is the heart of the Toyota Kata approach. Once training then is complete, most works emphasize that the transformation process should start small at first, using just a pilot group and containing just a few participants, so a small group on the company itself. Routines then must be practiced daily. Once the participants learn the routine, they can become coaches, and the process can be expanded to all the organization. Share lessons is essential. It develops the awareness of coworkers who will recognize the benefits of the Toyota Kata approach, and managers will also visualize the results and recognize the efforts of the workers. So several works also combined the Toyota Kata approach with other tools, methodologies. We highlighted some of them. One of them states that one of the authors try to implement continuous improvement in an organization without having a clear and defined vision is like driving your car without knowing your destination. You are only wasting gas. So to have this vision of the production system, the value stream mapping tool can be used so to better characterize the current state of the process, list problems, and characterize the status to be reached by the improvement team and by the Toyota Kata approach. Some authors argue that combining the Toyota Kata approach with the trees and agile methodology, the focus of the Toyota Kata approach so shifts from minor incremental improvements to continuous innovation, thus improving the performance of these combined tools. When analyzing that literature, it was also clear that stimulation for using the scientific method is necessary. So participants' mindset must change. For the more assertive, the better to predict the steps, to how it's actually important to use the PDCA cycles and experiments to reach the intended results and learn in the process. So this methodology has to be switched of the workers. On the organization side, so a doctoral thesis discussed that managers usually pay a lot of attention to the tools using, leaving the employees aside. So this is a problem with the lean approach. A lot of companies think that lean is like a toolbox. So you pick something like Kanban, you put in the process, and you think it's going to solve the problems. It's actually not that way. How Toyota did develop that tool, like the Kanban tool. So the mindset also need to be changed if a company wants to improve, the improvements to be lasting and continuous. Finally, the SWOT analysis. So we did search or actually aggregate the strengths, the weakness, the opportunities, and the threats when using the Toyota Kata approach. Some of them I will say in here. So the strengths are reducing processing time, work in progress, stocks, the implementation of a one-post flow piece system, generation innovative solutions. Toyota Kata does provide an organization alignment, do use short PDCA cycles that divide the work in small batches, develop a vision of what is expected. It's a new routine for continuous improvement, and short experiments stimulates improvement as a routine to the workers. Improvement process and communication among collaborators also. So the weakness part, so there is some kind of lack of direction and not using the value stream mapping tool and lack of routine meetings with the work team. So this needs to be, the company needs to find a way to better do these kind of things. Leaders often think that improvements only happens on the shop floor and that they don't feel the need to participate in the process actively. So they do ask to shop floor workers to use this methodology and not participate in using this methodology. It is hard for everyone involved to set clear targets, conditions, and at the beginning of the process, leaders feel that the benefits of implementing the Toyota Kata approach will bring quick and fast results, when in fact the results take some time to appear. So the opportunities, so it's a form of learning based on constructivism must be used. Employees must be encouraged and recognized when using the Toyota Kata approach routine. Leaders must participate in the process. It should be disseminated through our organization sectors with training on lessons learned to ensure its sustainability. And for complete immersion, gamification can be used to create a type of a lean game or something like that. And finally, the threat. So improvements tend to slow down with more complex challenges and accompanied by an increase of daily workload and stress. So from this content, it was possible to develop a first conceptual model that can connect manufacturing process with the best combinations between the Toyota Kata approach and other management approaches. So this is just a really, really basic model. The goal of my PhD is to develop a model to use the Toyota Kata and centralize the decisions on workers to implement technological or Industry 4.0 technologies, but this is just a small conceptual model based on this literature review. So as a conclusion about the content analysis, it was possible to better understand how the Toyota Kata approach is used in manufacturing environments and can be used to improve the efficiency of production system. However, to get there, some steps must be taken. It takes time to learn and understand the concepts of the approach. Once the approach becomes part of employees' routine and personal daily lives, the process will become natural for participants. And from the SWOT analysis, it was possible to list the main strengths of the Toyota Kata approach, such as process improvements, development of innovative solutions, focus and alignment of new routines to solve problems, using short experiments, and improvements of communication among workers. In contrast, the weaknesses and threats can be challenging for industry, especially for those who expect quick results. The conceptual model proposed can be used by companies that do want to start using the Toyota Kata approach combined with other methodologies to improve their processes. There is some limitation about this study, and the query used for the literature research phase may left the research spectrum too open, that just using Toyota Kata is very an open query, but some works that only proposed conceptual models were left out of this article, this paper, and few studies present discussions about Western companies as well. Content analysis may generate some interpretation bias. That's it.
Okay, thank you very much. The room is applauding.
Thank you.
And several hands are raised for questions. Yes, please.
Yeah, thank you. Thank you for your presentation. As you said in your conclusion, the approach is a little bit slow. So what will be the outcome of your thesis?
Yeah, so it's a problem that I have to solve because I will have something like 1 year to do my study, actually the study on the company. So this is why I already started the study, but it will be a study like 1.5 years, so not that long. So I don't know if I'm going to say as a conclusion of my PhD that use this approach, you solve all the problems. No, maybe we solve some problems. But I would not have data to say in the long term on my PhD thesis.
Okay, thank you. In the previous presentation, we had some methodologies about lean manufacturing and other tools connected. Why you don't compare your approach with those kind of approaches and see from the time perspective, from the result perspective, or any other aspect of impact, how to valorize better your approach? Because somehow we can say why we don't use lean manufacturing or VSM or automated VSM or others.
I don't know if I get the question.
Yeah, just a matter of comparing your approach with other ones, like the ones that we had in the previous presentation.
Oh, okay, so, but because what we think in our research group, that lean is not a toolbox. So maybe it's wrong to pick the Kanban and put in every manufacturing and hope that Kanban will solve the problems. Because each manufacturing process has its own properties and their own limitations. So to create new tools, we can use the Toyota Kata approach. This is what Holter says in his books, that Toyota developed their tools, the classical tools of the lean approach, using the Toyota Kata approach, using this way of thinking. So this is why I'm trying to use the Toyota Kata approach.
I get it, thank you. And last question, sorry for that. What's about automated VSM, value stream mapping?
Yes,
it's a tool.
It is a tool. So we can use these tools, but we have not just put the tool on the manufacturing floor and hope that everything is going to be okay. We can use this tool, but use the Toyota Kata to see this tool is getting where it needs to be, how it's everything happening, something like that.
Okay, thank you very much for your answers.
Thank you for your presentation.
Thank you.
In the last slide, you mentioned that so far there are only few publications about applications in the Western world. What is your interpretation of this?
So this was a comment from the reviewer, and he said that you have to search a little bit more about these companies, and we didn't have the time, so we put like a limitation.
So you did not, let's say, to say it critically, you did not spend the sufficient time really to check the comments of the reviewers. Yeah, okay, because it would be interesting for me as well. I was not the reviewer, to be sure.
Okay.
In the first part of your presentation, you extracted several kind of piece of text from different papers that you reviewed. My question was, is it just anecdotal statements, or is it thesis supported by objective evidence? Because it seems that it's very, let's say, superficial, and often I see PhD students, when they read a paper, some guys say this and they just report that. Is it what you did here, or the paper that you reviewed had a formal validation?
Not every paper, but like I was saying on the PhD workshop, my qualification has 140 pages. So it's more extensive than this paper. And there, on my qualification, I do show like numbers when people have used the Toyota Kata approach. But for this paper, I just bring some statements. I didn't have the space to go all the way to bring this kind of information. But it depends on the study. Not every study has like numbers to sustain what they are saying.
Yeah, but we don't know if your statements are sound conclusions.
No, they are not my conclusions.
No, they are sound conclusions from previous research, or it's just a piece of text that you borrowed in some papers and you concatenate these in a kind of sum up. That's not clear.
Okay.
Okay, next question. Okay, before moving on, maybe I have a question. Don't stay here. Don't move, please. Is there one of the co-authors of the third paper, Macroergonomics Approaches and Lean Manufacturing in the Perspective of PLM? It seems not. Okay, so you have a second chance to ask questions to the first speaker. Okay, Sébastien is still there. Yes, so you have a second chance to ask questions to Sébastien, and also you have additional possibilities to ask questions to Sousa. So, yes.
Thank you. Thank you very much for your presentation and also for yours. So my question is for you. What is type of deliverable, since you are in the enterprise and you are working with a laboratory also, if I understand well? Yeah, so what is the type of deliverable of your work? What are you going to do after your thesis? So what is the result?
So we want to implement a roadmap.
Yeah.
Sorry. So the delivery that we want is to have to set a deployment roadmap to know which tool apply depending the maturity level of the company and in which process applies them. So which one in first, after with the increase of the maturity level, lean maturity level of the company, which tool we can implement at this moment to have a progression in the capacity and in the to apply some tools and to improve processes. Yeah.
I will continue. So for the maturity of your enterprise, do you have some tools to evaluate it, or do you have any idea about its maturity? It's compared to maturity of lean manufacturing practice. Yeah.
So there exists some matrices to evaluate maturity. So we are actually trying to select the right matrix and to make a second survey to evaluate maturity level of our plant and other plant of Stobli, to make a comparison between the two, the both plant of Stobli.
So I have an additional question. CMMI? 5 steps?
Yeah.
Do you know 5 steps as well? Yes? Okay, because we have, this is a French method, okay. 5 steps. Okay. And CMMI could be also interesting to have a clear idea about the as-is situation and the to-be one, and to manage the transition. And maybe some recommendation as well. There are different plants concerned. I remember maybe 15 years ago, we did something not about lean manufacturing, but about capacity management, but it was how to involve the joint effort between the workforce and the technologies with Valeo. And we used also the 5 steps approach. And also we had a particular policy of communication to the different factories that were concerned, in order to generate some kind of emulation between the different factories, saying, they are doing quite the same than you, but they are better than you for that indicators and so on. Just trying to push people, to gain, to give more efforts and to be maybe more contributive. To integrate that new practices. Okay, so I mean the methods, we change, let's say, the technologies or the goals, but the method should be inspired by what has already been done in the past. So I would like to recommend to see what has been done for this kind of applications in the past. I think it could be interesting. Well, so finally we got one question from the room for you. Okay, so maybe for Sousa, do you have Raphael? I mean, it is Raphael, your name, Raphael. Okay? Because I don't know why it is Sousa in first, but anyway. Surname. Okay, Raphael, okay, that's fine. So any questions for Raphael, additional one? Maybe I have one. Concerning the deployment of your strategy and what you would like to evaluate. I know that Toyota has been very much productive in methods and so on in the past. Okay, maybe I'm wrong, but I think Pokayoke is from there now, maybe not. And also single minute exchange die, SMED also, and so on. Okay, so I imagine that Kata is also a way to help people in structuring good practices and sharing good practices. And once again, did you identify a methodology? It is quite linked to the previous questions with respect to the deployment of what you are going to find, in fact, or because you list tools, you list plenty of things.
Yes.
Are you trying to fine-tune things, or really to modify the way of doing, or is it a matter of just like lean, okay, the right thing at the right place, and so on, and or rationalization of the environment? What is the exact goal?
Yes.
And complementary question, what are the KPIs that you use to evaluate the success, okay?
Yeah, so right now in my PhD, I am in the phase that I did identify the problem. Okay. And I'm thinking about the solution. The solution is not ready yet. But what I am thinking is to use the Toyota Kata approach to centralize the decision on workers to implement the Industry 4.0 technologies. This is sort of like what Industry 5.0 is saying. We have to centralize in the workers. They have to be the leaders to say, I can use this sensor, I can use this Bloom tool. But there is no methodology from now, not methodology to do that. And I'm creating like a model to do that.
Okay.
I'm saying following these steps, you can be able to do that. And I'm going to do some use cases in companies in Brazil. But as I mentioned, I don't have that much time to do. So I think it's going to be a research after my PhD, it will continue it. So.
And do you know if they are already training their employees?
In the companies,
the company, yeah.
I did started training the people there, but now I will spend 1 year in Germany. So when I have to go back next year to continue the problem.
Okay. So I don't know if there are any additional questions. Do you practice lean manufacturing daily with companies? It's not new. It's not recent. Do you consider it is well applied in the companies nowadays? It is part of the good practices? Do you know good examples to share? In food industry, I don't know, in something which is not automotive or aeronautics? This is always the problem of illustration of this kind of concepts. You know, I have been teaching production management for years, and all the time I introduce a method, a SMED or a lean or whatever you like. What is interesting for students is to see practical applications and to also to evaluate the potential advantages or progress that you can get with that method. So on one side you have the effort, and on the other side you have the benefit. So the students that we have are, I don't know you, but concerning myself, it was more engineering students or master degree students. And these guys, they will have to convince their own employees to give efforts, to make efforts in order to adopt that kind of practices, okay? And I remember, for example, knowledge management. In the period of mid-90s when we tried to integrate knowledge management in the practice of people, frankly speaking, it has been very much difficult because people, they did not see any benefit of doing that, okay? Except sharing their knowledge and being, let's say, maybe more fragile with respect to their own employment, saying, okay, if I share my knowledge, maybe somebody else will catch that knowledge and take my employment. Okay, so it was very much difficult. And in addition, sometimes also the companies that did not see the benefit, short-term benefit, because they considered it is more losing time in spending some time in capitalizing or capitalizing knowledge and so on. So it's very much difficult to try to convince people to change their practices, and you may share also some interesting examples in order to highlight the main benefit they have for these practices. Any comments with respect to what I said? No? Yes, Klaus Dieter.
So our experience is very much, we had projects with Lean some 10 years ago, 8 years ago. And what we have done then was to integrate Lean with IoT applications. And this has created an additional benefit for the companies. And this was easy to visualize. And this wasn't a very important element. And this was even, let's say, this has even led to the fact that some companies who did not consider taking Lean into consideration to go for Lean, because in the combination with IoT applications, there was a real benefit. And on the other hand, my experience is that there are many methods and they have their ups and downs, and it depends on success stories, and it depends on promotions, and but the most important thing is we need to know that there are already very good, very powerful methods, and not just create another one. I think it's even better to understand the application of an existing method in a new environment.
Okay. So no remark concerning training of people and...
So the Lean is not a project that has a start, a middle, and an end. So it's a journey, and we can continuously be improving the process. So this is a problem. The companies usually think that the results will come like in 1-2 years, and actually I think it takes a lot of more time to do that. So I think it's another problem.
But I mean, what is I think what is very much important is to understand what it means. Okay, with clear example in practice and so on, and then afterwards you cannot avoid people being completely against the fact that they want to change. But deploying, for example, IoT and Lean connected, I don't know if you have good examples for construction, for example. I don't know. Myself, I don't know applications of connection between IoT and Lean manufacturing in the construction, building construction, okay, field. I don't know if you have some references, but I don't have. Guy-André, no? You don't have any input? Yes, automotive sector, yes. But it's very, very difficult. Remember what happens for PLM. Construction, they had very early CAD systems to design the buildings and so on, and to have even virtual reality applications to visualize a project and so on. But the link with operational deployment has been very much, let's say in English, very much delayed, in fact, with respect to aeronautics or automotive industry, etc. And the same also for even production management or even project management. And it is still the case at that time. Okay, they have some problems because it's much more a problem of training of people. People, they need to know the methods, and these methods are to become the daily practices, which is not really simple to develop in that field. It's a matter of basic culture of people. And PLM has been introduced also very late with BIM. Okay, we heard about BIM, Building Information Management, but it is PLM applied to construction. And nowadays, 1 or 2 years ago, I was leading some structuration of training priorities for different fields for the future in France. And all the demands for all kind of employment concerning construction, the first priority line was BIM. So for technicians, for engineers, and so on, the first line of priority was BIM. Okay, so this means that they had in mind to generalize the deployment of that, but just have a look to what happens to aeronautics. We heard about the Falcon 7X, which has been certified good for flying. I don't know if my English is correct, but you understand what I mean, without anything else than simulation. Okay, so it is unique, the unique and first one. It has been said by Guy-André this morning. So I mean, we know that in different fields, the deployment are completely different because the context of deployment is maybe more adaptable because people, they see more the benefit, or maybe, I don't know, it is a matter of culture mostly.
What I can say is in aeronautics, we have a long tradition in using simulation. The difference between the 20th century, the last 3 decades of the 20th century and now is the fact that the simulators are bigger in a sense that, you know, we were simulating, for instance, a system before, but not the whole aircraft. Today we can simulate the whole aircraft and fly it. So that's a major difference. But we had simulators for a long time. You know, especially for training. So in fact, the pilots are trained in lots of situations for anticipating incidents and accidents. And so this tradition shifted to the design, engineering design, incrementally. And but today it's really impressive what we can do.
Thank you. So I propose to close that session. I would like to thank you very much, and sorry, we apologize for the no-show paper. That's life. We hope that there is no problem for our colleagues, okay, from Brazil also. And I would like to thank you again for the good discussion. It seems that we have no news, so we will ask for news. And well, now it's time for a break, okay? And then don't forget to come back for the next parallel sessions. No. What is after that? Yes, we have 2 panels, okay? One in that room and one in the, what's the name of the second one, is GOS auditorium, okay? This one here will be related to technology, organization, people, triptych in Industry 4.0, and Thomas Reverdy is going to be the moderator. And the panelist, Guy-André, will stay here. I don't know, maybe he will move there. Aziz Bourras as well, and Bruno Villain from ADTP. And the other one in GOS Auditorium is related to model-based systems engineering with Clément Fortin, moderator, with Eric Muller from Muse Partners. I met him this morning. I don't know if it seems that he is not in that room. Klaus Dieter, he will be also part of the panel. And Maxime Cassé from Inetom. Okay? So, well, you have a binary choice. You have to choose between 2. It's better than choosing between 5. Okay, so the choice is limited. Thank you again, and enjoy the rest of the day.